So here's question 9, another straightforward calculation problem. So we're given the equilibrium constant, and then we're given the concentrations of 2 of these, and we want to solve for the third. So it's simply going to be SO2, and that's squared, times O2 concentration, times 1.7 times 10 to the 8th, and that's equal to the SO3 concentration squared. So again, take the square root of both sides, and that's going to give us the SO3 concentration that we need. So that's question 9. So for question 10, we're given another reaction. I'm going to go ahead and write this one down. And so I'm going to have this as CO, Cl2 is in equilibrium with CO and Cl2. And we're told that we start with 1.6 molar, and so that's our initial concentration, 0 concentration of these two, and then our change as we jump across those arrows will be 1.6 minus X, and then we're going to gain X, and we're going to gain X there, and then our equilibrium, I'm sorry, that's just minus X, and at equilibrium it is 1.6 minus X, and we end up with X over there. And so our K is given at 8.33 times 10 to the minus 4th, and that's going to be equal to X squared, or remember X is equal to the concentration of CO, that's what we're solving for, over 1.6 minus X. And we are told up here the answer is negligible compared to 1.6. So this is going to be a case where we say that's small. And we know that anyway because that's 10 to the minus 4th in our equilibrium constant. So we just rearrange this so it becomes, rearrange that, 8.33 times 10 to the minus 4 times 1.6, and that's equal to X squared. So take the square root of both sides, and that gives us our answer for what X is, which is what CO is. Okay, so here is question 11. So we have the following reaction at equilibrium. So we're going to have, in this case, two gas moles of H2S, 3 gas moles, total of 5 moles of reactant, and then we have 2 here and 2 there, both gases, so that's 4 moles. And what we're going to do in this case is increase the volume. So we've got the constant number of moles, that's going to stay constant in whatever volume we're in, and then we're going to increase that volume. So the pressure, total pressure, will drop. And in that case, the equilibrium will shift in a direction that will increase the number of moles, and that's in reactants. 5 moles of reactants make 4 moles of products. So by decreasing the pressure, it can react against that by increasing the number of particles, essentially, and so it shifts towards the reactant. Now in this particular reaction, this is question 12, we have what's says the delta H is positive. So that means it is an endothermic reaction, and in fact, the energy requirement acts in this case like a reactant. And then what it says is what will happen when we increase the temperature. So in this case, this is on the reactant side. We increase the temperature, so to reduce that amount of heat, it can consume heat by making products. So this reaction will shift to the right in the direction of products. Now, in fact, the answer is also true that the equilibrium constant will increase because products increase. But the answer that's the correct one that we think about is this one. The reaction will shift to the right in the direction of products.